Number 17 is a problem about tossing t-shirts at a baseball game through a slingshot, and it tells us that the height of the t-shirt is modeled by this quadratic function. It tells us that h of x, which remember is the same thing as y, is representing the height in meters. Now be careful with your units there, because a lot of times we've been dealing with feet, but this one specifically says meters. X is the time in seconds. So every time I give a time, I'm going to use seconds as my units. Every time I give a height, I'm going to use meters. And so every single ordered pair we know has an x and a y. The x is going to be our time in seconds, and our y is going to be a height in meters. So there are a couple of specific points that are of interest in this problem. And so there's two that I want you to find in your calculator. I want you to find the vertex of the quadratic, and I want you to find the solutions of the quadratic. So both of those are going to require you to put your quadratic into your y equals of your calculator. So remember that in front is a negative sign, negative 5x squared, then plus 35x plus 3.75. And always double check and make sure you entered it correctly. So the first thing I'm going to find is the vertex. So remember to look at your graph. If you can't tell, you should know by this sign in front that it's negative. It's going to be upside down. Now it's really hard right now. I'm in the standard window. You want to go to zoom 3 and enter so that you can see the vertex. Still can't see it. I'm going to zoom 3, enter one more time. Whoops. And it's really small, but I can see now that vertex at the top. And so I know it's a maximum. I knew that anyway because the negative sign flips it upside down. And so I'm going to go to my calc menu, second trace, and I want maximum. And again, I want to be on the left side and press enter, move it to the right side and press enter, and then just enter for my guess. So the 3.49999, that 9999 makes that 4 become a 5. And so that x coordinate is going to be 3.5. And I'm going to write this whole point down, 3.5. The y is simply 65. So that's going to be a really important point. So remember, as far as our time in seconds and our height in meters, the time is 3.5 seconds. The height in meters is 65 meters. Since that's the maximum point, that means that's as high as my t-shirt's ever going to get, and that's how long it took it to get to that height. Now I'm going to find my solution. So I'm going to go to my y equals, and I'm going to, in the second place, I'm going to put 0. That's the equation of the x-axis. I can tell by my graph that it crosses the x-axis in 2 places. So there are 2 solutions. So I'm going to hit second trace, 5, press enter 3 times, and if you'll notice, the first intersection has a negative x value. Remember, x is your time in seconds. It doesn't make sense to have negative time in this situation. So I don't want this solution at all. So I'm going to find the other one by pressing second trace 5, moving my cursor closer to the other point of intersection, and then pressing enter 3 times. So this one makes a whole lot more sense. I'm going to write that one down. I'm rounding to the nearest, does it tell me? The only time I see a rounding is right here, nearest tenth. So I'm going to round that to 7.10. Okay, so again, that x is a time in seconds. That 0 is a height in meters. So if the t-shirt is 0 meters high, that means it has hit the ground. And that's how long it took it to hit the ground, 7.1 seconds. Okay, so now I should be good to answer my questions. It says determine the time at which the t-shirt is at its maximum height. Maximum. Remember, that's what we call that vertex when it's at the top. This was my vertex. It's asking me for the time, so it wants me to give the x coordinate. So 3.5, remember my time is in seconds, is how long it took it to get its maximum height. Part C says, what is the shirt's maximum height if it's not caught? So it's still wanting that maximum point, but this time it's wanting the height, which remember comes from the y coordinate, and it's in meters. So it would be 65 meters. Part D says, what is the height of the shirt at 3 seconds? Well, this says 3.5 seconds, but it doesn't say 3, and this one's gone way beyond that, the 7.1 seconds. I still have my quadratic in my calculator, so to get when time, the height when time is 3 seconds, I can go to my table, which is in blue above graph. So hitting second graph, I can look at my table, and remember x is your time. And so here we have some negative times that again doesn't make sense. I'm wanting when my time is 3 seconds. So I'm going to go to x is 3. So when x is 3, do you see my time right here is my y value? 63.75 is the time. So 63.75, remember, is, I'm sorry, not the time, it's the height, and so it's in meters. So 63.75 meters. Now you could, if you wanted to, put this in your calculator and replace those x's with 3's, and you would get the same thing. So you could get out of this menu and just simply put -5, and every time you see an x, open it up, put 3, close it, and then continue with your quadratic. Plus 35, open parentheses for the x, replace it with 3, close it, plus 3.75. So I literally just took my equation and replaced the x's with 3's. And you can see I get the same thing, 63.75. Part E says, how long would it take for the t-shirt to hit the ground if it's not caught? So what is the height of the t-shirt when it hits the ground? It's 0. Remember, that was our solution. And so the time it took to get there is the 7.1 seconds, the x coordinate of that solution. Remember, don't give a negative time. And then part F says, from what height was the t-shirt shot? So when it is shot is before time has started with it being in the air. And so that's when x is 0. Time is 0. So if you replace these x's with zeros, when you square 0, you get 0. And when you multiply by 0, you get 0. So this whole term will become 0. This term will become 0. All you're left with is that constant 3.75. This is the beginning height. Your constant is the beginning height. So remember, that's 3.75 for the height. So that's meters, not seconds. And it's just your constant.